Hello, my name is Prateek Kalakuntla, and today I'm going to be talking about how to make your research a reality. So first, a little bit about me. I'm 18 years old. I'm a senior in high school. In other words, quite a bit younger than the rest of you. And I go to the Texas Academy of Math and Science. Essentially, it's a program at the University of North Texas that allows high school students to take college-level courses. It's been really great to me, mostly because of the opportunities I've gotten to do because of it, especially research. I've been researching for the past 2 years, and I've been able to do extremely well at some higher-level, prestigious high school research competitions, including the Siemens competition and the Goldwater competition, which is a competition for undergraduate students. And I've come to love research. It's something that I want to do for the rest of my life. However, in these past 2 years, I've also seen a lot of the problems in terms of research, and that's what I want to talk about today. So first, to understand my background with research, you have to understand my research. And to understand my research, you have to understand the problem that I was trying to help solve. So in rural communities, especially in Ethiopia and Somalia, mercury poisoning has become a real problem. Gold mining operations, known as artisanal small-scale gold mining operations, have been putting high concentrations of mercury into local water sources, summarily poisoning villagers who have no way of protecting themselves. Mercury poisoning has been known to cause renal failure, neural degeneration, and in some cases, death. There are currently 15 million villagers who are threatened of being infected, and this is a real problem that we have to solve now. The easiest way to solve this problem will be to give these villagers a way to tell whether or not their water is safe to drink. However, this isn't as simple as it seems. Currently, mercury sensing technologies are woefully inadequate. They are high cost, not easy to use, they tend to be non-portable and non-reusable, making them hard to use in these rural communities. To solve this problem, I helped create a mercury sensor, a luminescent mercury sensor. Essentially what it does is it emits green light, and when mercury is added to it, especially at low concentrations, the green light goes away, it becomes translucent. By correlating changes in concentration of mercury with changes in concentration of, or emission of the system, we're able to sense how much mercury is in a water source. This system is so effective because it's low cost, it's extremely easy to use, easy to make, and it's reusable, thus making it perfect for these rural communities. I personally thought it would be an easy step to take this system and give it to these people who really needed it the most. However, it wasn't as easy as it seemed. I thought all I would need to do would be to do a couple of field trials, prove that the thing actually worked in the real world, and then patent my project in a month and have it in the field as soon as possible. However, the first thing I reached, and my first big pitfall, was the patenting process. How many people here have tried to patent something? Yeah, that's what I thought, not very many. It's an extremely difficult process that can take months, if not years. And I went in not understanding this. I kept being asked the same questions. I thought my credibility was being called into suspect. And patenting just became a drudgery for me, something I really did not want to do. And so I did what I always do. I went back to my research. Patenting became a secondary process, and my research became my primary focus again. While this did mean I got to do some cool new projects, it also meant that my sensor was put on the back burner. It was stuck in the paper phase. Essentially, it never got to the real world. And this is something I've been trying to work on fixing. I have been getting back onto patenting the project, and I hope to have this patent done by summer of this year. But this problem, having the project stuck in the paper phase, isn't something that is isolated to me. It's something that a lot of researchers face. A quick Google search shows thousands, if not millions, of possible drugs that can be used to help cure cancer. However, we're still using the same chemotherapy that we've been using for the past 50 years, which has been shown to cause high levels of radiation poisoning, sickness, and in some rare cases, death. Why is there such a huge disconnect between the number of drugs we're producing, drugs that are being tested in laboratories, and the real benefits that we're seeing as society? these drugs are made to be given to the people. They're made to have practical use, and they're not getting to them. There's this huge bridge, and I believe that there's two main reasons for this. The first reason is the disconnect between the graduate school and PhD admissions and undergraduate and real-world application. One of the first things you learn as an undergraduate researcher is that the thing that graduate schools are looking for is who has created the most papers and who has them in the most prestigious journals. There's nothing about how much time you spent on a project or how much time you spent perfecting something. And so there's very little incentive to do just that. People are forced to drop projects after they've written the paper and move on to something new, because there's so much risk involved with taking the time to patent and market a project, where all that time could be spent creating a new project that can be used to pad one's resume. The next major thing is what I faced as a researcher. The fear of the unknown, and the unknown was the patenting process. Very few graduate researchers, and even fewer undergraduate researchers, understand how much work goes into patenting a project. And so once they realize how much work it takes and how long it takes, they start to drop out. They leave their papers stuck in the patenting phase, or they leave their papers stuck in the submission phase, and they move on to something new. And that's something that we need to fix as scientists. It's important that projects which have practical application get to the people who need them the most. Now, this is a huge structural problem which I can't solve myself, which we as a school can't solve ourselves. But there are small things we can do to bridge the gap, to make it so that these projects which do have practical application get to the people who need them the most. One of the first things we can do is have more panels for undergraduate and graduate researchers to meet with business interests. Now, this may scare some of the researchers out there, thinking that we're becoming beholden to business interests, something that many researchers are loath to do. But we have to remember that businesses do have something to give back to us as researchers. They can teach us how to market our products better, make sure that we have the correct procedural things to make sure that the project gets off the ground. And one of the main things they can help us with is understanding what we need to do as researchers to make sure that the project gets to the real world, whether that be patenting or field trials or just marketing. These are things that businesses do all the time in their R&D departments, and they can help us undergraduate and also graduate researchers do that as well. Another major thing that we can do, which may seem a little bit smaller, but which I believe is just as important, is having patent writing classes for graduate researchers. What this will do is remove a lot of the fear in the patent writing process. People won't be scared to write these patents anymore because they know what they need to do, they know the amount of time it will take, and that will just make it easier for them to justify taking their project and really working on it and really making sure it gets to the people who it needs to get to. In conclusion, we don't just need more science. What we need is more science that can really make a difference. And the only way that's possible is if we have science, if the projects that really can help people are getting to the people that they need to help. We need to be able to make our research a reality. Thank you.